Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we'll look at using the sine rule to solve problems in trigonometry. So you should be able to solve problems involving angles of elevation and depression and bearings. So I'm just going to go through a bearing question in this video, and I'll make it a bit of a challenging one, because if you can do this one, you'll be able to do anything else I throw at you. So let's do this question here. The angle of elevation to the top of a building is 30 degrees. If I walk 20 meters closer to the building, the angle of elevation is now 40 degrees. How tall is the building? So as we've always done when solving worded problems in trigonometry, if no diagram is given, we will draw one. So what we're after is the height of a building. So let's put building here and call that x. So the angle of elevation is 30 degrees. So we'll just make this into a right angled triangle as we've done before. This angle is 30 degrees. Now, so that's from that point there. If I walk 20 meters closer to the building, so let's say about here, the angle of elevation is now 40 degrees. So I'll draw that there. So I want to find the height of the building. Now this is a tough question. So the reason is because x isn't in the same triangle as the other side we're given. So we know that we have a right angle here because the building's going to be at right angles to the ground. So what we can do, our plan of attack, we could find this side here, because we have an angle and a side in this triangle here. So we'll find this side here, and then we can use this big right angle triangle to find x. So I'm going to find this side here, y. So I want to be able to use the sine rule to find y. So I need to know its opposite angle. That's easy. If this angle here is 40 degrees, then this angle here must be 140, because they're supplementary, they add to 180. So I need, in order to use the sine rule, I need this side and its corresponding angle. So this angle up here will be 180 minus 30 minus 140. It'll be 10 degrees. I have a side, its opposite angle, and I have the opposite angle of the side I want to find. I now have enough information to use the sine rule to find y. So remember, when you're finding sides, they go on top. So it goes y over sine of its angle equals 20 over the sine of its angle. And remember, I solved this really easily by just multiplying each side by sine of 140, because after all, it's just a number. So when you multiply a fraction by a number, you only multiply the top by that number. So I'm going to put this on my calculator. So to 2 decimal places, I get about 74.03, and that's obviously in meters. So that is this distance here. That's 74. So now I have that, I can find x, because I have a big right-angled triangle here. I have an angle and a side. So I can find x using normal SOHCAHTOA. So compared to this angle here, x is the opposite, y is the hypotenuse. Opposite and hypotenuse means I use sine. So sine of angle equals opposite over the hypotenuse, which I just found was 74.03. So when the thing you want to find is on top, you times. So x will be 74.03 times sine 30. And that gives you approximately 37 meters to the nearest meter. So the building is about 37 meters tall, and that's all there is to it. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.